Hello viewers, you are welcome to today's class. In today's class, we are going to be talking about Homologous Series. Now, if you are new to our channel, just click subscribe and then click the notification button so that anytime we post an educative video like this, you can be the first to get notification about it and get value out of it. So, this is Chemical Scholar, and today we're talking about Homologous Series. Homologous Series is part of organic chemistry, and you know organic chemistry is a very vital aspect of chemistry. Okay, so let's get down to business. Okay, so we're talking about homologous series. What is homologous series? Now, when you talk about homologous series, we are talking about homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differs this molecular formula by a CH2 group. So when you talk about homologous series, you're talking about a family of organic compounds. Just like in a normal family, you see that a family, you have people that behave almost the same way or have the same character. You see that these people are a family. In organic chemistry, you have families like that, and such families is referred to as a homologous series. They differ for each successive member differ from the next member by a CH group. That is to say, if the first one have one C, that's a carbon atom, and then have a hydrogen molecule, two hydrogen molecule, then the next member will now have two carbon atom and four hydrogen molecules. So that is what we mean by that. It differs from each other by the CH2 group. Okay, so that's what so let's look at some of the examples of homologous series. Okay, so here we have homologous series and we have a general molecular formula. Okay, so you can see alkanes. The first homologous series is alkane. Okay, and alkane has the general molecular formula of CnH2n plus 2. Okay, so when we talk about N, this N here simply represents numbers. Okay, it can be C1, the N can be 1, it can be 2, it can be C2. So any number, as long as it's a positive integer, that's what N represents. So N can take value from 1, 2, 3, 4 till any number at all. Okay? So the general molecular formula for alkanes is CnH2n plus 2. And then for another example of a homologous series is alkanols. Alkanols also can be called alcohols. Okay? So this alcohol, the general molecular formula is CnH2n plus 1 OH. So anytime you see an organic compound that has OH, then you know that it's talking about alkanols, and that's a homologous series. Okay, so the next example is alkanes. Okay, we have alkanes with a general molecular formula of CnH2n, and then we have carboxylic acid with a general molecular formula of CnH2n plus 1 COOH. Okay, so these homologous series have what we use to know them, or what we call the characteristics of the homologous series, or we can call it features of homologous series. So let's take a look at the features of homologous series. So the number one feature is that all members of the homologous series conform to a general molecular formula. All the members conform to a general molecular formula. For example, let's take a look at the family, the first one that I use as example here, which is the alkane family. Here, we can see the general molecular formula to be CnH2n plus 2 as general molecular formula. So assuming the N here is 1, so we have the first member of the family to be CH2. Okay, that's CH2 plus 2H, which is equal to CH4. Okay, so which means this is CH4, and CH4 is called methane. Okay, it's called methane. That's the first member of the family. Then the successive member, if we use the successive member, that's the next member of that particular group, will now be the one that N will represented by 2. And if we substitute 2 into these things, we will now have that this is the first member. Then the second member will now be C2H2N, that's H4 plus 2. That is to say that it is C2H6. Okay? C2H6. So you see that the difference between the first member and the second member is a CH2 group. Okay? So and this one is called is what we call C2H6 is what we call ethane. Is what we call ethane. So and so on and so forth. If you keep substituting them, you see that they have that all members they conform to that general molecular formula, and that's the number one feature of homologous series. Okay, so let's take a look at the second one. The second feature is that each member differs in the molecular formula from the next member by CH2. I've already explained this, and then this in its relative molecular mass by 14. Okay, so if each member differed from the next member by the CH2 group, then of course the relative molecular mass will differ by 14. Okay, let's check it out so you can get this. Okay, let's check this out. Okay, so since each member differs from the other one by CH2 group, and of course the relative molecular mass of carbon is 12, and then the relative molecular mass of hydrogen is 1. And here we have 2 hydrogen. Then you now have that 12 plus 1 times 2, okay, which is of course equal to 14. So we say that this relative molecular mass differs by 14. Okay, so the third feature of a homologous series is that they exhibit similar chemical reactions. Like if you come to the homologous series, let's say you take the alkyl families, you see that they have similar chemical reaction. They undergo similar chemical reaction. Like if you go to methanol, if you check the way methanol reacts is very much similar to the way ethanol reacts, and it's very much similar to the way propanol reacts, and so on. So we say that they exhibit similar chemical reactions. Okay. So the next feature is that they have a general method of preparation. Okay, the way you prepare the other one is the way you prepare the next member. It's still the same way that you prepare the next member. So they have a general method in which you can use to prepare each member of a homologous series. Okay, so the last one is that the physical properties of each member changes gradually as you move, as the number of carbon atom per molecule changes. Okay, each member, their physical property keep changing as they keep adding carbon atom. Okay, the first members maybe like for example, let's use the alkane family. Their first member is a gas which is methane. Their second member, ethene, is also a gas. And as you go on and on, you get to a state that as the carbon atom keeps increasing from 1, 2, 3, and you go to a stage, then it will turn to liquid at room temperature. And as you go on adding the carbon atom, at some point when it will now change to solid, you now see that some of the members are now be solid in room temperature. So that is what we mean when we say that the physical property of the member changes gradually as the number of carbon atoms changes per molecule. Okay, so this is where we draw it today on homologous series. So just make sure you subscribe to this channel so that as we run a series on organic chemistry, you will not miss anything. So see you in our next video.